Okay, went and helped Blake with her work, and now I could help you again. In order to answer this question, I just highlighted in red choice 1, the 2 points, choice 2, orange, green, and then blue. And I already put them all in the calculator, so I didn't have to do it while I was being recorded. So for instance, for choice 1, I subtracted the y's, the 1172 number minus the 2591 number, and then I divided it by 10 minus 60, and so on. I did that for each of the choices, and then at the end, I found that choice 4, 45.7, was the greatest rate of change. I'll be right in. I'm not pausing again. Okay, so that's choice 4. Next one, number 2, they gave us a table again. Distance needed to stop a car after applying the brakes. Determine the average rate of change in braking distance in feet per mile per hour between one car traveling 50 miles per hour and 70 miles per hour. Explain what this rate of change means as it relates to brakes and distance. Okay, so I'm going to do the 156.25 minus the 306.25, subtracting the y's, over 50 minus 70. So it doesn't matter, I could have reversed both top and bottom. Okay, I like to hit the division sign first. 156.25 minus 306.25 over 50 minus 70. And I get 15.2. I don't know why it keeps giving it to me as a fraction. I press the purple, it gives me 7.5 or 7.5. So what this means is that the average rate of change is, there's a difference of there is an increase of an average of 7.5 feet per each mile per hour the speed increases. Because it's positive, the change is representing an increase. If it was negative, it would show a decrease, okay? So sorry for my very sloppy writing. There is an increase of an average of 7.5 feet per, sorry, it shouldn't say per each. 7.5 feet each mile per hour, the speed increases. Okay, one more I'm going to try to get through before Blake ruins it. Which function shown below has a greater rate of change on the interval -2 to 4? So f of x is shown by a table, so I'm going to use this point on the table and this point on the table. So to get the average rate of change, 80 minus the 1.25 divided by 4 minus the -2. So get the calculator. I'll use pink for the next one. So 80 minus 1.25 on top, 4 minus -2 on bottom. So the average rate of change on the first function is 13.125. For the g function, okay, I might do it the way that I did before, or you could just get a table of values for it and do it the same way I just did for the other one once you put the function in and get the table of values. Minus 5x squared plus 3 equals. So for this one, I'm going to do g of, what were the two values? G of 4 minus g of -2, and then I'm going to put that over 4 minus -2. Okay? In the calculator, though, I'm going to have to use f of x. I bet I could go up and change the name to g, so I could use the same notation that I wrote. Okay? So I'm going to put the letter g, because I changed it to g of x, g of 4 minus, I'm glad I'm putting you to sleep, Blakey, g of negative 2 over 4 minus negative 2.
Much math.
And this gives me 38. So it says which function has a greater rate of change? That's g of x, and the work we just showed is the justification. Okay, please comment with any questions if you have, and you could do the homework by tonight. It's 6 of these.